get this. We're diving into Attention is All You Need Today. The title alone, I gotta say, had me hooked.
Yeah, it's a pretty famous paper, for good reason.
Yeah, and it's all about this model called the Transformer, and like apparently it just blew up the AI world when it first came out.
Yeah, definitely did.
So like what we're going to do today is figure out just what's so special about this Transformer thing and why it's had this massive impact on, get this, everything from Google searches to protein folding.
It's pretty wild. The Transformer really changed, like, everything.
Okay, so before we, really get into the nuts and bolts of how it works, can you like set the stage for us? What was the problem that these researchers were even trying to solve when they came up with this whole Transformer thing?
So they were tackling this thing called sequence transduction, basically taking one sequence of things, like a sentence in English, and turning it into another sequence, like a sentence in French, a translation.
Okay.
And before the Transformer, everyone was using these things called recurrent neural networks, or RNNs.
Yeah. RNNs. Okay, yeah, I remember those. But like, what were their problems? Why weren't they good enough for this kind of translation stuff?
Well, the big issue was speed, especially with longer sentences. RNNs process information sequentially, kind of like how we read a sentence, word by word. And just like people, the longer that sentence gets, the harder it is for the RNN to keep track of everything.
Yeah, totally. I totally zone out if a sentence is too long. So how did the Transformer fix that? Like, was it just like a superpowered RNN or something?
No, not at all, actually. What they did was they kind of threw out this whole idea of recurrence altogether. Instead, they came up with this really smart mechanism called attention.
Okay, so this attention thing, that seems to be like the secret sauce, right? But before we get into that, I got to admit something.
Sure.
Whenever I hear attention, my brain just goes straight to, like, meditation. So, like, how does that even apply to a computer model?
It's actually a pretty good analogy. Think about how you pay attention when you read. You're not giving equal focus to every single word, are you? Your brain kind of picks out the words and phrases that seem the most important to understand the whole thing.
So the Transformer's kind of doing the same thing.
Yeah.
Figuring out which parts of that input, are most important.
Yeah, exactly. Instead of going word by word, the Transformer can look at the whole input sequence at once and figure out which parts are related.
So it's like having a superpower to see the whole puzzle at once, not just having to put it together one piece at a time. It's got to be way faster.
Oh, it is, for sure. Being able to parallelize computation is a big part of what makes the Transformer so different. But the real magic is how it actually uses attention.
Okay, let's unpack this attention thing then, because it's still a little fuzzy for me.
Yeah.
Like, what's happening in the model?
So they use this thing called scaled dot product attention, which might sound kind of scary,
Yeah, a little bit.
but it's actually pretty intuitive. Imagine you're trying to find something in a library, right? You have this query like the history of the Transformer model.
Okay.
So to find the best books, you'd compare that query to the titles and descriptions in the catalog, right?
Yeah.
So in this analogy, your query, that's what you're looking for. The keys are those titles and descriptions. They help you find the relevant stuff. And the values are the actual books themselves, the information.
So every time it processes a sentence, the Transformer is doing a library search.
Kind of, yeah.
Yeah.
It compares parts of the input to find the most important connections, just like you compare your query to the library catalog.
Okay, so scale.product attention is like the Transformer's way of figuring out how words connect, basically. But then the paper also mentions multi-head attention. Does that mean the Transformer has multiple personalities or something?
Not quite. But it's a fun way to think about it. Multi-head attention is like having a whole team of experts, all looking at the same problem from different angles.
Okay.
Instead of just one attention head, the Transformer has many. And each one focuses on a different aspect of the input.
So it's like having a whole team of translators all working together.
Exactly. Each head captures a different kind of relationship between words.
So by combining all their perspectives, the Transformer gets a much better understanding of the input.
Exactly.
So this attention thing is pretty impressive. But is that all that's going on in the Transformer? Is there anything else that's part of this recipe?
Well, there are a few other key ingredients. Along with attention, the Transformer uses these things called position-wise feed-forward networks. Don't let the name intimidate you, though. They're actually pretty simple.
Simple is good. So what do they do?
Think of them as like little processing units that take the information from the attention mechanism and refine it. They help the model really understand those connections the attention heads found.
Okay, so it's like attention highlights the connections, and these feed-forward networks help make sense of them.
Yeah, you got it.
Got it. And what about those embeddings I keep hearing about? They're like translating words into a language the model can understand, right?
Right. Word embeddings basically turn words into numbers. It's like giving each word a code that the model can work with.
Turning words into numbers so the transformer can do its math. But wait a minute. If the transformer isn't going word by word, how does it know the order of the words? That's got to be super important, right?
Totally. Word order is key, and the transformer handles this with positional encodings.
Positional encoding. So it's like
Yeah.
giving each word a little tag that says, hey, I'm the third word in the sentence.
Exactly. They add these special signals to the input to mark each word's spot, like little location markers, so the model doesn't get lost.
That's really smart. Okay, I'm starting to get how the transformer works, but why is self-attention specifically such a big deal? Like, what makes it so different?
That's a great question, and it gets to the core of why the transformer is so revolutionary. Remember how we talked about RNNs being slow?
Yeah, because they process everything one step at a time.
Right. Well, self-attention throws that whole problem out the window. It lets the model see every word in the sentence at the same time and work out those relationships in parallel.
Oh, okay.
So it's way faster, especially with longer sentences.
So the transformer basically has super speed compared to those old RNNs. And that's all thanks to self-attention.
Yep. And it's not just about speed, it's also way better at catching connections between words that are far apart. Imagine a really long sentence where the subject and verb are miles apart. An RNN would have trouble remembering the connection, but with self-attention, the transformer sees it instantly.
Okay, I'm starting to see why self-attention is so cool.
Mm.
But did it actually work? Like, did the transformer make better translations than the old RNNs?
Oh yeah, way better. The results were groundbreaking, actually.
Okay, tell me, what happened?
Well, on one of the standard tests for machine translation, the transformer score was over 2 points higher than anything that came before.
Hold on, what's that score? Remind, why do we even care about that?
Oh, right. It's called the BLEU score, and it basically measures how similar a machine translation is to one done by a human. So, higher score, better translation.
Gotcha. So a 2-point jump is, like, huge.
Oh, yeah, huge. And the crazy thing is, the transformer did all this while being way faster than the old models.
So smarter A&D faster. Sounds like an overachiever.
It really is. And get this, it's not just good at translation. The researchers tried it out on a totally different task called English constituency parsing.
Constituency parsing. That sounds complicated. What is that?
Basically, it's about figuring out the grammatical structure of a sentence, you know, like breaking it down into phrases and clauses.
Oh, okay. Yeah, I remember doing that. So the transformer can translate and ED. It can understand grammar.
Yeah, and it did really well on that task, which means it's learning something deeper about how language actually works, not just translating word for word.
Okay, this is blowing my mind. This transformer sounds almost too good to be true. But the paper also mentions attention visualizations. What are those? Like graphs and charts and stuff.
Yeah, they're really cool. It's like you can peek inside the brain of the model and see the attention mechanism at work.
Whoa, that would be awesome.
Yeah.
So what do they show us?
Well, there's one that shows how different attention heads focus on different parts of the sentence to get the meaning. You can actually see the connections the model's making, even between words that are far apart.
Whoa, so you can actually see the model thinking.
Pretty much. And some attention heads even seem to be involved in figuring out pronoun references, like when it or he refers to something earlier in the sentence,
Right, right.
which is something that even humans struggle with sometimes.
That's amazing. This is all really impressive. But I'm sure there's even more to this transformer and what it can do. Like, we need a part 2 for sure.
Definitely. There's so much more to explore, but I think we've given our listeners a lot to think about for now. What are you most impressed with so far?
Honestly, it just blows my mind that a computer model can be this good at understanding language. And the fact that it's good at so many things, translation, grammar, it's crazy. How about you?
What I find really interesting is how this idea of attention is so simple, yet it's so powerful. Makes you think, if attention is so important to how WE understand language, maybe that's why the Transformer's so good at it too.
Whoa, deep thought. Maybe the transformer is more like us than we realize? But before we go too deep into that, I think we should let our listeners take it all in.
Yeah, good idea. We'll be back soon to explore more of this amazing Transformer world.
Okay, welcome back. I'm still kind of geeking out over how this transformer thing can figure out grammar and even like pronoun references. It's like it's learning to think like a human.
Yeah, it's really amazing how far natural language processing has come, all thanks to the transformer. But it's not just about building, like, super smart machines. It's about opening up new possibilities and solving real problems.
Okay, so that's a perfect lead into my next question,
Okay.
actually. We've talked a lot about how the transformer works and all that, but like, what does it actually mean for people? Why should we even care about this technology?
Right, that's the big question. The transformer isn't just some academic thing. It has the potential to change, like, so many parts of our lives.
Okay, give me some examples. What kind of impact are we talking about?
Okay, well, let's start with something everyone uses, like Google search. You know how you can just type anything into Google and it seems to know what you mean, even if you mess up the words or whatever?
Yeah, it's kind of freaky how good it is at figuring out what I'm trying to say, even when I'm not that clear.
Well, that's because Google is using a transformer-based model called BERT to do its magic. It stands for Bidirectional Encoder Representations from Transformers, which is a mouthful, but basically it's a language superstar.
So BERT is like Google's secret weapon for understanding all our messy searches.
Pretty much. It helps Google understand the context of words in a sentence so it can give you better results.
That's pretty cool. So next time Google blows my mind with its search results, I can thank the transformer. What else? Are there other real-world examples like that?
How about something even crazier? Protein folding. You know how scientists are trying to figure out how proteins fold into these like 3D shapes?
Yeah, I've heard of that. It's like important for drug development and stuff, right?
Exactly. The way a protein folds determines what it does, and figuring that out is super complex. It's like a giant microscopic puzzle.
And the transformer can help with this. Like, how?
Okay, so proteins are basically long chains of amino acids. And those chains fold into specific shapes based on how those amino acids interact. It's kind of like a sentence where the order of the words really matters. And guess what? The transformer is awesome at understanding sequences and relationships.
Ah, I see where you're going with this. So it can use those powers of attention and all that to look at these protein sequences and figure out how they might fold.
That's it, and it's already making a difference. Researchers are using transformer-based models to make real breakthroughs in drug discovery and disease research.
That's amazing. It's like the transformer is a superhero scientist.
Yeah.
But let's not forget about language stuff. We talked about translation, but what about things like writing? I remember hearing about this model called GPT-3 that can write poems and even code.
Oh yeah, GPT-3, another rock star in the transformer world. It stands for Generative Pre-trained Transformer 3, and it's this massive model that's been trained on tons of text data.
So it's like the transformer went to school and read every book ever.
Uh-huh. Pretty much. Because it's seen so much text, it can write stuff that sounds like a human wrote it on all sorts of topics. People are using it to write poems, stories, articles, even computer code.
That's amazing and kind of scary too. If machines can write like humans, like what does that mean for us?
Yeah, it's a question a lot of people are asking. These models are getting so good so fast, it makes you think about the future of, well, everything. Work, creativity, what it means to be human.
Whoa, that's getting pretty deep. We might need another whole deep dive just to talk about that. But for now, let's stick with our transformer tour. What other cool transformer models are out there?
Well, there's this really impressive one called XLNet. It's like the Transformer's attention powers got even stronger.
How so?
So XLNet builds on the original Transformer, but it uses this technique called permutation language modeling. It's a way for it to look at all the possible orderings of words in a sentence, and that helps it understand those long-range dependencies even better.
Sounds complicated.
Yeah.
But, so the takeaway is that XLNet is even better than the original transformer at understanding how words connect.
Yep. And it's made big improvements in things like language modeling, summarization, question answering, all sorts of stuff.
It seems like the transformer family is constantly growing and getting more powerful. It's hard to keep up.
It is. But that's what's so exciting about this field. It feels like we're on the edge of some major breakthrough in AI, and the Transformer is leading the way.
Okay, I'm totally on board with the transformer hype train.
Yeah.
But I also got to be realistic, right? Every technology has its downsides. What are some of the challenges or problems with the transformer?
Right. It's good to think about that, too. One thing is, it can be pretty computationally expensive, especially with really long sequences.
So even though it's faster than RNNs, there's still a limit to how much it can handle.
Yeah. For really long sequences, like whole books or massive data sets, it can become a bottleneck.
That makes sense. What about, like, understanding how it works? We talked about those attention visualizations, but Is the transformer still kind of a black box?
Yeah, that's a valid concern. Even with those visualizations, it's still hard to fully understand why the transformer makes certain decisions.
So it's like we have this powerful tool, but we don't always know exactly how it works or why it makes the choices it makes.
That's the problem, and it's something researchers are working on. This interpretability thing is really important, especially if we're going to use these models in areas like healthcare or finance, where you need to understand the reasoning.
Absolutely. So what's next for the transformer? Is this the end of the line, or are there more improvements and new stuff coming?
Oh, this is just the beginning. Researchers are always looking for ways to make the transformer better and do more with it. For example, they're working on more efficient versions that can handle those super long sequences.
I'm making it even faster.
Exactly. And they're trying to add other kinds of information into the transformer too, like knowledge graphs or external databases.
So giving it even more knowledge to work with.
That's the idea. The more context these models have, the better they'll understand language.
This is so fascinating. But I think we need to take a break to let our listener process all of this. It's like we've been on a whirlwind tour of the Transformer universe.
Yeah, I agree. Let's take a break and then we'll come back to finish up our deep dive.
Okay, so we're back. And I gotta say, this Transformer thing, it's even more amazing than I thought.
Yeah, it really is something else. And it's just gonna get bigger, I think.
Yeah, definitely. So before we, wrap things up here, I want to make sure we've got it all straight. We've gone from like the nitty-gritty of self-attention to real-world stuff like Google search and even protein folding.
We've talked about BERT, GPT-3, XLNet. It's a whole family.
It is. So as we finish up, what are the big things you want our listeners to remember? Like the big takeaways from all of this?
I think the main thing is that the transformer really changed how we think about language processing. Before, it was all RNNs, one word at a time. But the transformer showed us attention is all you really need.
Attention is all you need. It sounds so simple, but it's obviously really powerful.
It is. Being able to focus on what's important and process stuff at the same time, that's what made such a huge difference.
And that's why we're seeing these crazy results, right? Like the Transformer was the best at machine translation, but it's also good at so many other things.
Oh, yeah, for sure. Natural language understanding, protein folding, even writing poems in code. It's just super versatile.
It's wild to think about what's next, for the Transformer, for AI, for everything. Any guesses or hopes for what we'll see in the future?
I think we'll definitely see more specialized versions of the transformer, fine-tuned for specific jobs and areas. We might even see them combined with other AI approaches.
So basically, the Transformer is going to keep evolving and getting smarter.
Exactly. And as that happens, we got to make sure they're understandable, transparent. As we start using AI more and more, we need to know how it works and why it makes the decisions it does.
Makes sense. We got to be able to trust these AI systems, especially if they're making decisions that affect our lives.
Exactly. Trust, transparency, those are going to be super important.
Well said. Okay, so last question. As we close out our deep dive, what's one final thought you want to leave our listeners with?
How about this? If the transformer's so good at understanding human language, does that mean it's getting closer to, like, real intelligence? Or is it just a really complex tool that's mimicking us without really understanding?
Whoa, that's a big one. We're getting into deep philosophical territory now.
We are. And that's part of what makes this field so cool. It's not just about building machines, it's about understanding ourselves, too.
Well, I think that's a perfect note to end on. We'll leave our listeners with that question to ponder. Thanks for joining me on this amazing journey into the Transformer.
It was my pleasure. Love talking about the future of AI and what it all means.
And everyone listening, we hope you enjoyed this deep dive as much as we did. Keep learning, keep exploring, and keep those questions coming.